Develop the transfer function for the block diagram shown in figure using first block diagram reduction technique, then Mason's gain formula. First, let us find the transfer function by using block diagram reduction technique. Here, the innermost loop we have to first find. This is the innermost loop. This is the innermost loop. They are in parallel. It is not feedback. Two forward paths. Two forward paths. That's why this is equal to G2 because of 90 negative sign G2 minus G3. This block is reduced to G2 minus G3. Here in the feedback path, one additional path is coming in. That's why forward path is coming in. That's why we cannot simplify this. That's why this part must go. This part must go. To remove that, this is summing junction. This is also summing junction. That's why first we have to draw like this. First we have to draw like this. H2, H1, here G1, G2 minus G3. That's all. This H1 is moved to here as well as here also it will come. That's why this will become G4, then H2, H2. It is going here. These two are them. This is minus sign. Here also one minus sign is there. Here this is minus, this is plus. If you, that's all. What we did is H2 is moved here as well as here also. We are moving the H2 ahead of summing block. That's why H2 coming in both. Now we can interchange these two. We can interchange these two. That's why this block becomes like this. This block becomes like this. G4, H2. Here one minus, another minus is there. That's why this becomes plus. Then this summing block coming here. We moved the summing blocks this way. So we can write here G1, G2 minus G3. This is H1, H2. This is negative feedback, one negative only. That's why this is negative feedback. This is positive forward path. That's all. Now this becomes 1 plus G4 H2. This becomes 1 plus G4 H2 because this is 1. These two are parallel. That's why 1 plus G4 H2. And this is R of S. R of S. Then this is equal to seventh law we have to use. Feedback path we have to remove that. That's why G1, G2 minus G3 divided by 1 plus G1, G2 minus G3 multiplied by H1, H2. If you multiply these two together, what you will get is in the numerator 1 plus G4 H2, 1 plus G4 H2 multiplied by G1, G2 minus G1 G3 whole divided by 1 plus G1 G2 minus G1 G3 multiplied by H1 H2. This is the overall transfer function. C of S upon R of S. That is equal to C of S upon R of S. That is equal to, if you multiply by 1, you will get G1 G2 minus G1 G3 plus G1 G2 G4 H2 minus G1 G3 G4 H2 whole divided by 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. That's all. This is the required transfer function by block diagram reduction. We have to check whether we got the same relation for Mason's gain formula also. First, let us convert this into signal flow graph. 2, 3, 4, 5, 6, 0. This is 7. This is 7. That's all. Now we have to take all the 0, 1, 2, 3, 4, 5, 6. This is C of S. C of S. And this is R of S. 0 is R of S node. And 7 is just here. This is 7. 0 to 1 gain is 1. 1 to 2 also gain 1. 2 to 3 G1. 3 to 4 G2. G2, another G3 is there. That is minus G3 because we are negative sign is down. Then 4 to 5 unity. 5 to 6 also unity. From 5 to 7 H1. 7 to 2. 7 to 2 minus H2. Minus H2. 1 to 7 minus G4. That's all. Now, what is Mason's gain formula? T of S equal to 1 by delta sigma Pk delta K, where K is the number of forward pass. Here, number of forward pass equal to how many we have to find. Here, this is one forward path. This is one forward path. This is another forward path. This is another forward path. Second forward path. This is third forward path. Third forward path. This is fourth forward path. This is fourth forward path. There are 4 forward paths. Therefore, K equal to 4. K equal to 4. P1 first forward path equal to 1, 1, G1, G2, G1, G2. That's all. So, plus G1, G2. Delta 1 equal to the part of graph which is not touching the forward path is 7 only. There is no loop. That's why that is equal to 1. P2 equal to what? Second forward path. Second forward path is G1 minus G3. That's all. Minus G1 G3 delta 2 equal to the forward, the part of graph which is not touching the forward path is 7 only. There is no loop. That's why 1. P3 equal to what? P3 equal to minus G4 minus G4 minus H2. Therefore, this becomes plus minus H2 G1 G1 G2. That is one forward path. Here delta 1 delta 3 equal to again 1 because there is no forward part of graph which is not touching the third forward path. P4 equal to what? P4 is plus G4 H2 G1 G3. G3 is minus, that's why here you will get a minus sign. Minus sign. That's all. Delta 4 equal to what? Delta 4 part of graph which is not touching the forward path is and doesn't consist of any loop. That's why that is also equal to 1. Now we can find delta. Delta equal to all loops. The first loop is this is not loop. This is two forward paths in parallel. But H2 is in loop. H2, H1 is in loop. That's why G1, G2, H1, H4 is one loop. We will write all loops first. L1 equal to H2 is negative. H2 is negative. That's why minus G1, G2, H1, H2. At the second loop is we are going to use this path. This path we are going to use. Therefore, minus G3 also minus. That's why 2 minus it becomes plus G1, G3, H1, H2. G1, G3, H1, H2. One more loop is there. That is no, everyone is meeting at G1. We cannot use this path to find a loop because if you go through this, again we are traveling this path again. That's why only 2 loops are there. Therefore, 2 non-touching loops, nothing. Therefore, delta equal to 1 minus of minus plus. That's why 1 plus G1, G2, H1, H2. Minus here plus, that's why minus G1, G3, H1, H2. That's all. Therefore, T of S equal to 1 by delta. Delta equal to 1 plus G1, G2, H1, H2 minus G1, G3, H1, H2. Numerator G1, G2, delta 1 is 1 plus minus G1, G3, delta 2 is 1 plus G4, G1, G2, H2, 1. One more term is there, that is plus G4, H2, G1, G3 multiplied by 1. That's all. If you write the numerator, what you will get is G1, G2 minus G1, G3 plus G1, G2, G4, H2 plus this is minus G4, H2, G1, G3 is minus. Here minus. Here also minus. Therefore, minus G1, G3, G4, H2. whole divided by denominator 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. We compare with the previous result, numerator two negative terms, yes, this is there, this is there, this is also there, this is there, this is there, this is there, this is there. Therefore, both are equal. In both ways, we got the same result. That's all. Let us see afterwards.